Hello everyone, my name is Zhixuan from ByteDance. In case people don't know, ByteDance is a company who make TikTok. And my topic today is bringing Lynx to desktop and beyond. The first question is that what is Lynx? The Lynx here is not the terminal browser, but a cross-platform engine that wants you to write code once and build UI or applications running on any platform. It solves the same problems that the web, React Native, Flutter, and all many other things are trying to solve. And it is freshly open sourced earlier this year. So Lynx is widely used in TikTok. For example, that Lynx is used in the eShop, the search page, the advertisement, or the major event, such as Met Gala or the end of year event. So Lynx has three major features here. And the first is our platform support. We support Android, iOS, and web, and our performance and our web-inspired design. Let me introduce from the web-inspired design. It means that developers can get like web-like coding experience by using Lynx. So here is the demo that the front-end code is writing in React and using Lynx. And Lynx will run the React code into a native UI. And also the developers can write the real CSS here and to steal the native UIs. And then it's the performance. Lynx has a unique dual-thread solution to solve the performance problems of front-end. Like Lynx, instead of having only one single runtime, JavaScript runtime, Lynx actually have two different runtimes running on two different threads. The first one is the main thread runtime, which runs on the system UI thread. And the main thread runtime will provide a set of API, which we call it Lynxtron API, which enables the front-end code to interact with the native UI. And the second runtime is a background runtime. And the background runtime provides native module which interact with the system utilities such as network or storage. So when the front-end code is compiled by Lynx, it will be compiled into two different scripts. And one script is for the user interaction high priority task, which includes the first screen rendering and the user interaction handling. And it will be run on the main thread, the main thread runtime, as well as the system UI thread. And another part will be compiled into the background runtime, a script running on background runtime. It will execute some lower priority tasks, such as event set effects. For example, if I have to make a network call, it will be running here. So by drawing a clear line between those two kind of runtime, we can always have the high priority task, which handles the user interaction running on the main thread and throw away all the time-consuming tasks into the background. So by this kind of architecture, we can achieve such things. And all those pages is implemented using front-end techniques, but we still can get instant first screen rendering and instant event handling without latency. So as a conclusion, Lynx is a dual-thread UI renderer based on WebDX. So my topic today is about extend Lynx to desktops and beyond. And how did we achieve it is by mapping the Lynxtron API into a component. We call it Clay. Clay is a library that we fork from Flutter and transform Flutter into a UI widget library, which render UIs into texture. As people may notice, we use native UI on mobile, but we use custom join UI on desktops. But why don't we use native UI also on desktops? There are some cross-platform engines do use the native UI, for example, Java SWT, the React Native. But still, there are some other cross-platform engine, like using custom join UI, for example, Qt, Electron, and Flutter. So in my personal opinion, the most favorite framework to code a desktop application is Qt and Electron. So they are both using the custom join UI. But why? So my reasoning to it is that desktop suffers a lot from the system UI fragmentation, where desktop's operating system has a longer history, so with more legacy, and we have diverse operating system here. So as a result, like user has less system fidelity on desktop's design. For example, like the Android coders will follow the material design and using the HIG on iOS, but like when developers are developing the desktop application, it seems like there is no clear design guideline for the UI. And for the developers, it also makes things get a lot more harder to make their native UI running on different version or different flavor of the operating system. And also for the cross-platform engine maintainer, things get even harder because we want to let developer write once and run everywhere. So we have to make things consistent among different platforms. So with the UI fragmentation, it's just too hard to achieve that. So with custom join UI, we get a lot of like consistency over platforms. And it is also easy to adapt our techniques into another platform. So by using a cross-platform techniques with custom join UIs, the coders can get better developing experience as well, make their application work in more platforms. So that's two very important thing to developers. And I am going to show two cases by our company. The first case is the CapCut. The CapCut is a video cut software. It is popular among TikTokers, and it is written using Qt. Yeah, by using Qt, we actually coding natively, so we get a software with high performance, small application size, and short startup time. But there are costs. We cannot be very productive with Qt. Even Qt has its QML, but we have to write a lot of C++, which is not very productive comparing we are using JavaScript, coding always front ends, using web, right? So the developers want the WebDX to make things more productive. The second case is the Douyin. It is the Chinese version of TikTok, and it uses Electron to build its PC client. So with, Yeah, by using Electron, it gets really high development productivity. And also, the PC client can share large part of code between the desktop with the web version. But the cost here is that the Douyin application suffers from a very long application startup time and a very high memory consumption. But we don't settle down for that, right? So can we have the best of the both worlds, the best of web and native? So when we are using the native techniques, we want to have web developer experience. How should we do that? My answer to it would be to use Lynx. So Lynx do provide a set of like multi-platform APIs, which allow Lynx to be embedded into any frameworks or adapted to any operating system. So by embedding Lynx into the Qt, the CapCut can have their front end, their UIs written in front-end techniques using Lynx. So there are a bunch of like actively working pages that is running on Lynx. what about the other way? When we are using front-end techniques, but we still want the native perf. Oh, all right, but I won't say that Electron's performance is really bad. Actually, I am a big fan of web technology, so I would say Electron is very fast in some cases, but there we do have some complaints about the Electron, right? So let me jump into what is Electron and say what's the trouble here. So Electron is a combination of Node.js and Chromium, where they use Node.js to let developers to write their main application logic, and use the Chromium to render the UI to let the developers write the web page to render the UI. So it would have two kind of process. One is the single main process, where the browser main and the Node.js or the system UI is running here. And within the Node.js environment, the developers can use a browser window where the UI will be rendered within the browser window. And the browser window is corresponding to a renderer process, usually in Chromium. And the renderer process will have the full web development environment provided for the developers. So can we see the problem here with the architecture of Electron? So the problem here is actually here, that the Electron will provide all the functionality for the full side of web application may needs, but when you like native application don't need that functionality, you cannot strip it out from your binary. So that's my personal thinking, that browsers are operating system because they can run any random URL and run them as a web application. So it has to provide the full functionality and also maintain the standard and security. So as a result, it would suffer from a large binary and a lot of service to be initialized when starting. And also the native access have to be restricted to maintain the standard and security. But we are actually developing a native application using Electron, right? So what we want is we want the functionality we need bundled within our installer, but since we don't need, just removed away from our binary, right? So here that we can get back to the to this page. So we use Electron use Chromium to render UI, but Electron here is actually an operating system. It is just too heavy for Electron. So what is needed here is a UI renderer with web developer experience. So I would say Lynx would be a perfect fit into that part. So we get another product, we call it Lynxtron. So here is a demo of Lynxtron. The upper one is the Douyin running on Lynxtron. The startup time is halved by just migrating from Electron to Lynxtron. That would be the first feature I would introduce for Lynxtron. It is lightweight and fast. So the architecture of Lynxtron is very like to the Electron. The only difference here is that Electron would new a browser window, but Lynxtron would new a Lynx window. As I earlier mentioned, that Lynx is a UI renderer, so it does not have any other functionality other than the UI rendering, but still, like front-end coders have to have other utilities to code their front-end. So when it is needed, it can be extended by using native modules to extend the Lynx runtime. The native modules can be implemented directly using the system native API, or we can simply have a bridge back to the Node.js, where we can get the full capability of Node.js And also, we can get the full ecosystem from the Node.js. So we can get the things to work, just support as many things as Electron do in Lynxtron. And here is a code example here. Axios is a very famous front-end library running on Node.js and browser, which provide network functionality. And we can have Axios imported into Node.js and expose the APIs to the Lynx runtime, and everything get to work. But we can get even things more better with this kind of architecture. As I earlier mentioned, Lynx provides some like DOM API to interact with UI on the system UI thread. This still holds true in the architecture of Lynxtron. We can let the developers write code to handle the user's input immediately. And the second thing we can get from the architecture is that we can have the Node.js also running on our background runtime, where we can do some like native module, Node.js require file system, and we get a real JS object from Node.js. Yeah, but people may question that Electron do provide a flavor to have the Node.js running on the renderer process, but in practice, not a lot of people are doing this because like browsers can load an URL from an external source. So by having Node.js in the runtime environment, you are allowing like attackers to have a native system access, which is not really good. But Lynx is only a renderer, which means Lynx doesn't provide a standard capability of load an external URL or an external JavaScript resource. So it is perfectly fine for Lynx to do that. Then I will tell, after the introduction of the architecture of Lynxtron, I'm going to tell the migration story of the Douyin. Douyin is a very complex application. When they migrate from Electron to Lynxtron, it needs an incremental way to migrate it. So how do we do that? Is that by having the most important UI migrated to Lynx, but still we are leaving part of UI rendered using web. And how we suppose that is by having a web view as an extension to Lynxtron. Yes, Lynxtron itself does not have any support for web view, but we can have a web view as an extension. That would be the second feature I want to introduce for Lynxtron, that is natively extensible. Let me give you another example here. So if I want to write a really cool image editing software, then I need to have a very good canvas here. So I can, with the web techniques, I can implement the canvas using the web canvas component or the web GPU. Or I can implement the canvas natively by using Vulkan, Direct3D, Metal, and OpenGL. So in the case that we want to make a tools for Pro, the later one is always preferred because it gives us full native hardware access where we can do like deep optimization or implement some cool features. So if we abstract out the model, it would be like we have to have an external tester rendering with frontend. And all the interaction or users logic have to be handled by the frontend because it is easier to run frontend code. And to have this kind of architecture in Electron, we do have some ways to do that. One is using the Chromium Pepper plugin API, but it is deprecated and recently already completely removed from Chromium. And the second way is that having a standalone window which covers upon the browser. But we will find some interaction cannot even be implemented in this way. For example, if I have a front-end component which is covered upon the front end and as well the external tester, it is completely not doable. And there is a third way that is to customize the browser. So there is simply no good way to do such things, right? But with Lynx, just as a native UI renderer, we are providing the extension C APIs, which we provide our life cycles, where the extension maker can register their extension or do some initialization here. And we are providing some like UI or testers extension API where the extension maker can have their tester embedded into Lynx. And the Lynx runtime is also exposing a subset of Node API, which the developers can write code in the open source standard to have their JavaScript function exposed to the front-end coder. And with those kind of APIs declared in C, so we can have the extension repo publishing its definition of JS and their binaries, compiled binaries to NPM. And for the front-end coder using Lynxtron, what they need to do is just to do an NPM install and import it in the front-end code. Without any touching of native code, the things get magically working for this for the project. So here is the demo here. So we require the binaries in front end. We have the UI declared in the front end code, and the from front end methods are provided to interact with the interact between the external tester and front end. We can have a external tester running within our front-end code, and all those like kind of interaction is implemented using front-end techniques, and all the interactions get smoothly. So that would be two things I have previously introduced. Lynx is lightweight and fast, and natively extensible. But we are still missing something. The Electron is using Chromium as renderer. It can share code between the web version. So can Lynx solve this problem? Yes, because Lynx actually supports the web platform. So that would be the third thing that I would introduce for Lynxtron, is that it is multi-platform. So here is a demo that we do provide like Lynx wheel on web, and it is implemented solely by using front-end techniques. And with the native module bridge on the web application, then we can get the MPC versions, renderer code working inside a browser. So you can see it is running in a browser here. And all the elements here are browser DOMs, HTMLs. Cool. So by combining two things together, we can get things really crazy that Lynx can be embedded into a web view, and the web view can again be embedded into Lynx, which sounds mind-blowing, right? And for the multi-platform, actually, there are more platforms such as Android or iOS. And we have some other use case where the front-end page, like TikTok, Live, Gift, something like that, running inside the mobile. But we have a software called Live Studio that is provided for TikToker to stream their video. And the same part of front-end will be shown on their PC client. Yeah, so that's multi-platform. So today, I have introduced two production here. One is the Lynx multi-platform C API, and the second is Lynxtron, and we are open sourcing it by the end of year. But at the end of talking, I think I have missed something here, right? Yeah, where is the Lynx? we do have some cool use case where the Lynx running on Linux. It's like we have Lynx running on Linux as a cloud service, where we render the front-end UI into video frames, and stream the video frames into the user's mobile phone. But still, we don't have really like implement the UI interaction, the real UI on Linux. So if my today's talking can convince you that Lynx is an exciting technology and it would be cool to have Lynx to write UI on Linux, then contribution or collaboration are super welcome to make Lynx on Linux even better. Thank you.